All right, so we're going to continue on with standard deviation in this video. And in the previous video, you noticed, it was a long and lengthy process. And that was just with a data set of 10 numbers. So as we add more and more data pieces, it's going to take longer and longer. So we want a quicker, more efficient way that we could find standard deviation. And just like the mean and median can be found in your calculator, the standard deviation can also be found in your calculator. So let me show you that in this video. So it says, suppose the heights in inches of students in a stats class are as follows. So the first person is 62 inches tall, the next person is 63 inches tall, all the way up to somebody who's 78 inches tall. We can use our calculator to find both the mean and the standard deviation. These seem to be the appropriate center and spread in this case because, it seems we got these 70s toward the middle. If you look to the left of that, you've got some heights in the 60s down to 62. To the right of that, some heights in the 70s up to 78. No huge jumps here. I mean, you have a 4-inch jump here at the end, but it's not a big jump. So the mean and standard deviation are fairly appropriate for this. So to find the mean and standard deviation, the first thing I'm going to do is get my numbers into my calculator. So just like we did for the mean and the median, we'll hit Stat and Enter to edit. I've got these old numbers in here from a previous video, so I'll hit Up and Clear and Enter to get rid of those. And I'll just enter in this data set starting with 62 and then 63 until I have all of my numbers in. We've got 15 numbers here. Let me just double check everything looks good. Seems to be the same data set. So now the standard deviation is actually in the same place as the mean was. We can go Stats, over to Calc, and we select that 1 bar Stats. We hit Enter until our values populate. Our mean is the X bar. So X bar is the mean. And in this case, the average height is 69.2 inches or 5'9.2 inches. And then the standard deviation is also on the calculator screen right now. It is the S sub X, that 4.39 value. So the standard deviation is 4.39. So what we're saying is, the average height for the class is 69 inches or 5'9", but this varies. Not everybody is exactly 69 inches tall. So we've got people below that height, people above that height. How much are they typically above or below that? Well, that's 4.39 inches, and it can give us a range of values. So if I take 69.2 and I subtract 4.39, gives me 64.81. And if I add those two together, 69.2 plus 4.39, it gives me 73.59. And so we're saying, because the mean was 69.2 and the standard deviation is that, most of our class should be between 64.81 and 73.59. And if I look back at my numbers, just starring the people who are in between those, 66, 68, 70, the 71s, the 72, the 73. These values are all within 1 standard deviation of the mean. You've got 3 people below and 2 people above, but 10 out of 15, 67% of the class within 1 standard deviation above or below the mean. So together, these two are a powerful combination showing you where most of your values will be. And that takes us to Chebyshev's rule, which it says for any data set, no matter the shape, if it's skewed left, skewed right, uniform, bimodal, symmetric, at least 75% of the data is within 2 standard deviations of the mean. So going up another standard deviation and down another standard deviation, up and down 2, that should capture 75% at the minimum, no matter what. And in this case, it looks like we would get to almost 100%. I don't think we would get that 78. We get close to it. And then at least 89% of the data is within 3 standard deviations of the mean, and at least 95% of the data is within 4.5 standard deviations of the mean. So we can use these guides to see, what percentage of our data should we have at the minimum. We'll expand this further in the next video with the empirical rule, which is a rule that will come up again and again in the course.